Good morning, everyone. My name is Wang Kang. I work for Auditable Group as a security researcher. My research focusing the IoT, V2X, and cyber physics systems. And together joining me on stage is Dr. Yang from CAICT. And we are more than happy to share our research with you about the auditable and provable privacy of smarter speakers. And the outline will be the first. We will provide some background check and the motivations of the privacy violations of the big tech giants, including the SEC filings, patents, and some voices from our paranoid users. And after that, some case study about the risk of those smart speakers will also be introduced. For the first time, we will reveal a new risk surface. We call it the hot mic. We will walk you through about the technology behind it by Dr. Yang. Finally, the methodologies of the auditable and provable privacy designs will also provided to you as a reference. So, and the auditable means the authority could use the help from the manufacturers, so they can audit if the designs is solid enough to protect your privacy. And the provable is another story, because users can directly prove the solidity of the privacies by his own eyes. So, we will learn from these good designs, and we hopefully this could be of some inspirations for you. The background of the smart speakers. Now, the smart devices are everywhere pretty much in your home, like the smart plugs, smart bulbs, and smart refrigerators, and air conditioning, and even a lot of smart things. So, the big companies are now building smart speakers. Behind the motivation, I think the smart speakers will be the new center of those smart things. So if we get the smart speakers, we can get the center, we can get all the data from those interactions. So the data become the crucial part of the competition of those vendors. And after that, the technology regarding this massive voice, face, and video surveillance. Oh, did I say surveillance? The video processing is mature enough. Let me show you this. If this is an example of the real-time voice processing directly using my laptop microphone by the web page from Google. I think this is a very interesting function for us, but this also indicates that the technology is mature enough for now. So another motivation of the potential privacy violations, because a lot of the PR articles or the news for the big companies, they will not tell you I think they won't tell you the truth. But I think the only thing they won't lie is from the investor relationships, like the SEC filings. So, I got this from the Alphabet, the SEC filings. They say the goal of our advertising business is to deliver relevant ads. And as of the year of 2016, the 88% of the total revenues is from advertising. And as of the year of 2017, the number a bit lower, but still very big number part of the 86%. And they say they generate revenues primarily by delivering both performance advertising and brand advertising. So the performance advertising is the users will click on, right? The relevant ads. So the relevant ads basically needs to follow your users to directly to guess what the user will look like. They have to collect a lot of data to analyze. So I think this is one of the motivations. And as for another giant, they say we generate substantially all of our revenue from selling advertising placements. So nearly 100%. I don't know the substantially. I think it is very big partial. These are several patent filings, patent applications from those tech giants. On the left side, it's indicated that if they want to know which TV program you are watching, they will embed some ultrasound fingerprint into the video, into the audio of the TV program, then collect the relevant ultrasound, the fingerprint, by your phone. Then they will guess which TV program you are liking. And the second one is another patent. If your smart speaker hears you are coughing, they will ask you, would you like a receipt or a recipe for chicken soup? If you say no thanks, they will, if you say yes please, I think they will probably place an order for you. But I think this is a very sweet function, but I am a bit of paranoid about this data they are collecting. And for another case of the patent, they even collect your hand, your temperature, or your pressure, your heat of your hand to guess whether if you are angry. If you are angry enough in a supermarket, they probably will give you a coupon to calm you down, I think. And as of several days ago, the judge orders the companies to turn over the recordings of the. I think this is a legitimate one. So, but if the judge orders, they have to follow, right? And as for our paranoid users, there are two examples. On the upper left, a couple that they never have been talked about the cats once they opened the iPhone. And the Facebook, they say the cat bite. Do we consider to adopt a cat? Then after a few minutes, the cat advertisement come through the timeline of the Facebook. And the down one, this guy has never a dog guy. He didn't like the dogs. So he is on a broadcasting, and to show his viewers that in a paper, he said, I will say the following words a minute, and after he read the dog toys, the advertisement of relevant of the dog, the foods and the toys come through the browsers, the sidebar. So let me play this one. I speed it up.
Okay, so this phone is my wife's, and we think Facebook is listening to us and taking keywords from our conversations and then putting in suggested ads to Facebook. So we're going to do a test here. And all day, we're going to talk about cat food. Because we don't have any cats. We never search for cats, especially cat food. So let's find out. All right, so all day, we are going to be talking about cat food. Because I could use some cat food.
Well, the cat is almost out of food, so
we might need some cat food.
we should buy some cat food.
I should call somebody and ask if they know where to get cat food. And there you have it, cat food. So I guess Facebook does listen. Oh, by the way, this came in 2 days later, I think.
It was the day before yesterday we talked about it.
Yeah. There you go, cat food. Meow. Okay, so I just want to make it totally clear that.
And this one is the live one I just talked earlier. So skip to the.
Okay, how's it going, everybody? Today I'm going to be doing a live test to see if Google is all.
So this one I have just mentioned earlier. They do another experiment by another parent users. So I think that the users, the experiment is not solid because we have to do a lot of samples, a lot of the experiments. We have to get the access to the relevant algorithm, the data they collect, and other stuff they have. But if we have the sufficient evidences or the sufficient materials, we basically are the big companies themselves, right? So what they are going to do is prove themselves. So apart from the motivations by the manufacturers, there is also some risk, even if the manufacturers can be trusted, can be innocent. So there are 4 different types of risk, in my opinion. There are rules risks, the firmware, the software, and the hardware. For example, this is some research group published work on the Usenix security a few months ago. They set up a new attack surface called skill squatting. For example, this skill, the smart speaker skill called boil an egg, and the squatted skill will be the boil an egg. So it's very easy for the smart speakers to misunderstanding which the skill should be invoked. So if the malware, the adversary's speaker, the skill writers, they wrote a squatted skill, maybe they will collect your data. And some other words like call, and the he'll, and he will, and so on. I think this is a very interesting attack surface we have never noticed before. And for another case study is the eavesdropping skills. A group of researchers from a company called Checkmarks, they said they set up a skill and use the should end session set to false. So after the skill is invoked, it will not stop automatically, and they re-permit so the speaker won't say anything during the entire process. So all of the data will be passing through to the servers of the skill writers. So this is another case. And as for if you have the physical contact, you have the serial port, you can do a lot of things. A few years ago, last year, a British hacker managed to get the physical access to the first generation Echo. And for the firmware override, the security researchers from the Tencent group, they soldering the chips, the flash chips off the board and integrate the malware code into the flash chips, then boot again. The root can be done. So this is case studies of if you get the physical contact of the speakers. And this is a recent research from a group of researchers indicating that the sound from the microphones, because the AI technology is being used in the smart speakers, the sound is sounds like the "How are you?" but it's actually be recognized by the smart speakers as "Open the door." So basically, this group of people is trying to separate the sound from a speaker like your phone, your other speakers, or it's rarely from your voice directly. So this is another interesting work. So these are the 4 risks. So the hardware risk, I want to review our original research by and they will be introduced by Dr. Yang.
Okay, thank you. Good morning, everyone. Comparing to the rules risk, firmware risk, and software risk, the hardware risk may be a little difficult to understand. So in the following slides, I will show what we have done recently on the smart speakers. We all know that each smart speaker has got a mute button on it, and the mute button is considered as the last defense protecting your privacy. Just consider when should a user press the mute button. It has to be before something important that the user don't want the speakers to hear, right? So it acts like a scram stop button on a machine. But does it eliminate all threats? This is the basic hardware structure of a smart speaker. We can see there are several microphones there. There may be MAPS microphone or piezoelectric microphones. They pick up the surrounding sound. And the ADC, analog digital converters, converts this analog signal into digital ones. And all this information are transmitted to the CPU via some kind of audio bus here. What we basically do is we investigated the signal transmission via the digital audio bus between the ADC and the CPU. In the smart speaker, we investigated, it was an I2S bus. The I2S bus, the inter-IC sound is some kind of a synchronous signal digital audio transmission bus. There are several important signals in there. There's word clock used for synchronize the channel, and the beat clock used to synchronize each beat and then the date. The samples of the sound are transferred sequentially. Different channels can be transferred on the bus with different offsets. So multiple some signals from multiple microphones can be transferred via one line, via one wire. So when the speaker is muted, there should be completely nothing in the I2S bus, right? But actually, we'll see the demonstration here. Yeah, as we can see here, in the oscilloscope shows what is being transferred via the I2S bus. And when the smart speaker is not muted, there is some signal transmission in there. And here we press the mute button. There's still something there, right? I need to do some explanation here, because this kind of problems we found exists in several smart speakers from several manufacturers, so we don't want to specify any name here, any brand here, so there's a little blur in there, but there is a smart speaker, and a quite popular one.
I think I will speed it up a little bit.
And we can see there are less and less information is being transferred.
Totally died down. Now, yeah.
After 2 minutes, there's completely nothing. Okay. Okay, I'll do that. So there is something still being transmitted via the I2S bus, as the digital audio signal transferred via the bus is not encrypted. We tried to restore the sound waveform. This is what we have got. In this experiment, someone is clapping beside the smart speaker. And in here, the mute button is pressed. And we can see after the smart speaker is muted, there is still something in here, although the volume has been dimmed a lot. So what's in here? I got another experiment. In this experiment, somebody is talking about something. besides the smart speaker. And here the mute button is pressed. We can see a very tiny signal here, but after amplified, we can see there is something there. And could you please play this waveform? Okay. I guess anyone who is able to speak Mandarin can tell that this is someone counting numbers in
1、2、3、4、5、6、7、8
Mandarin
like this
Chinese. So it does carry some information. And what about other signals? In this experiment, some DTMF signals, which used for coding the numbers, are used. This is the original sound. On the left side was the original signal, time domain and frequency domain. And on the right side is the signal recorded after the smart speaker was muted. And we can see in the time domain, we can hardly see anything here. It's almost a noise. But in frequency domain, we still can find some information. Can anybody hear anything? Yes, right? Yeah, maybe using some signal processing algorithm, this would be more clear. We did completely nothing in filtering or processing this sound. Okay, a little summary. A deeper investigation towards this problem shows this thing isn't brought by the manufacturer on purpose. We don't think they are doing it on purpose because the vendors are quite responsible. They cut off the power supply of the microphones immediately. The mute button is pressed, but this thing still exists. We think it could be caused by some kind of discharging on the capacitor on the printed circuit board. So we call it a hardware design flaw instead of some kind of backdoors. And we don't think some significant harm has already been done because the signal has been dimmed and distorted a lot. But this still violating the expectation of the vendors and also the users. Most importantly, as an end user, the user are not able to stop it or even get aware of it. The countermeasure for this thing would be quite simple. Just turn off the DAC, the ADC, disable the ADC immediately when muted. That would eliminate everything, the signal transmitting on the I2S bus. But here is the problem. When the smart speaker is doing something bad, like here listening to the surrounding sound, the user doesn't know. If it's doing something good, like turning everything off, the user still doesn't know. As we have mentioned before, the confidence from the customers becoming vital recently, and some manufacturers started to try to prove themselves innocent to promote their sales. How to do that? There are typically two ways. A traditional way and easy to think is to find a trusted audit authority to prove them clean. However, this may not be easy in a private protect scenario. And the second way is do some self-proven work. We'll talk about that later. We have investigated several audit services in the smart speakers. There are potential audit service may include the cloud data center, the network traffic, hardware bus, firmware, the mobile app, and source code, of course. But only the bolded two items, the network traffic and hardware bus, can be audited independently by a third-party auditor, because all other items, if you want to audit it, you want to see it, you have to get the technical support from the ODT, and that would make the result of the auditor less trustworthy, right? Network traffic monitoring. We have done such experiment on some smart speakers. If your traffic is something like this, I dare say that this smart speaker is something less suspicious because it transfers. This is the silent flow. When someone have conversations around the smart speaker, but the smart speaker is not awakened, it transmits some signal to the cloud regularly with almost a fixed interval, and each packet is too small to carry any audio information. So I guess this smart speaker is not that suspicious, but the story isn't always like this. Nowadays, the smart speaker is usually used as the gateway of the home IoT. So some smart speakers are transmitting something always. And since this data packet are encrypted, we have no idea what's inside. And hardware bus, yes, we have investigated the hardware bus like S2S, where we found the hot mic problem. There are some advantages of investigating the hardware bus, like the signal between the chips doesn't lie. If the signal is there, the signal is there. There is something transmitting. And there is no need that to find the help from the ODT. And the hardware bus is innumerable. There are no fragmentation problem here, but it does have some limitations. First, so we need to do some reverse analysis in the hardware. We need to know where's the bus, what's the signal, and we need some luck. And second, the heterogeneity and function integrated ASIC. Maybe some days later, if a smart speaker application is popular enough, there would be an IC integrates every function inside. There would be completely no inter-IC bus there. In that case, there's nowhere we can find the signals. And most importantly, black box still exists. Even we have proven that there is something transmitting in the I2S bus, we still have no hard evidence to say that the CPU is processing these signals or something is being uploaded to the cloud, right? So it is not a silver bullet, but it is still a missing point. Okay, here, maybe we should reverse our thinking. What the manufacturers want is the trust from the end users, not the trust from the auditors. So how does the end user, how does the general user trust something? We all know that in our laptops, there is an LED beside your camera. It lights up when the camera is being invoked, right? Do you trust that? I don't. And neither does Mr. Zuckerberg. He uses a very tiny tape covers the camera. How does this little tape being better than the sophisticated privacy protection mechanism inside the laptop? because it's instinct. Everybody could understand that the camera cannot see anything. At least it cannot see anything clearly once covered by this tape, right? So to earn the trust from the users, why don't we just integrate this kind of tape in our design? So what we are proposing is that in each design, there should be some kind of privacy sign. It may be an indicator. It may be a blocker. And the coupling between the privacy date and the sign has to be trustworthy. There are two ways to do that, which is physical coupling. This kind of method is very hard to spoof and easy to understand and believe, just like the tape. There could be some electrical contact or electrical coupling, like using an LED indicating something transmitted in the bus, or it can be some kind of mechanical design, like some kind of a plug-in or eject mechanism. And what we are using today are mostly virtual coupling, which is controlled by software. This is kind of suspicious. That needs audit, like the trusted software that the API provided by the operating system, or trusted firmware like TEE or Enclave. And there could be some secure chip like Apple T2 recently reviewed. And in the following slides, my colleague Mr. Wang would introduce some examples for these designs.
Thank you. And as for physical coupling, I think this one recently happened in China is a phenomenal design, because when the cameras is being used, the camera will be lifted up from the front case. So I think this is basically the idea of the power of user awareness, because a lot of users in China are now using these phones just to test whether the apps is take a snap when you are not noticed. Actually, they did find a browser, the camera lift when it's not a good timing. So the manufacturers of the browser even investigated in this issue, and it turned out to be it's a mistake in their API calling. They're calling the API twice, so they fixed them. So I think this design is very well, and so I want to give you some of you the basic idea of the future of the smart speakers. If we want to have some similar designs, maybe we could like these designs. If the microphones is being used, it should be pulling down and with physical contact through electricity, and the microphone daughter board is being powered on, and the microphone is in use. And if you are not want to be heard, you can lift the microphone up, or if the mute button is being pressed, the microphone daughter board will lift up. So this is a very solid idea, so the user could directly believe or trust these designs if these are no other microphones inside. And this one, the other idea is the virtual coupling. Like this one, this is my iPad. When someone is recording at the background, there will be an indicator, the right icon. But this trusted coupling is bounded to the operating system. If we have to trust the operating system API, we have to trust the Apple software. So the link between the operating system and your end users, this link should be audited. So this is recently released Apple T2 inside each of the new released MacBook. When you are case is closed, the microphone, the power of the microphone will be shut down by the Apple T2 chip. But I think this is a very good design. It's auditable. Yes, it makes sense. If you want to audit the T2 design, the wire connections, I think it is definitely auditable. But it's not that provable for the end users because we end users don't have the enough ability to directly prove that. So anyway, I think this is a very good approach to the provable designs. Actually, this is just released in the last month, I think. Basically, I think the provable designs is a better one, but the auditable is a superset of the provable designs. If it is provable, it must have been auditable designs. In a Latin words, it reads "Brasipsalo quidol." It means it can be proven by yourself. So I think manufacturers of the smart speakers or AI system should be aware of the provable designs because every provable design is a better design. So our key takeaways of this talk is the first, the detection of potential privacy violation will be an everlasting problem. The manufacturers will adding up new functions, which requires the use or the collections of the user privacy. But the paranoid users will still be paranoid all the way. We have to convince them to be trusted and to provide enough information for the future function. And the second, for the first time, we have revealed a new threat in smart speakers. We call it hot mic. Even if we think it's not a very big deal, but I think this should be told to the relevant manufacturers to design, especially when the mute button is pressed, we have to shut down the relevant ADCs. And the third is the concept of the methodologies of the auditable and provable designs. We hope this could be inspirations for the future designs. Okay, I think we have a lot of time. Maybe we should take some questions. Thank you. Okay, thank you.
Hi. Sound which you recorded after, yeah. So sorry, everyone. So how did you ensure, or did you even test that the signals you recorded after the mute button is pressed are not just electricity generated by the magnetic elements in the microphone? Because when you press the button mute, the magnetic elements in the microphone might still generate electricity, and that might be the reason for your signals. Did you test this theory?
Okay, so it's a good question. In my understanding, your question was, how can we prove that the signal is from the microphone, right? So because our wire is connected to the link between the ADC and CPU. So if we only collect the digital signal from the ADC, the output of the ADC chips. So the microphone part, we don't have any wires or test wires on them. So I think.
Yeah, but there might still be even microscopic traces of electricity generated by the microphone itself. You know, it's a physical magnetic element which might generate electricity, and that might be it might go all across the boards. Just traces of electricity.
Yeah, I think that whether this sound is generated from microphone or not, there is a simple fact that even after the mute button is pressed, the CPU can still get some valid and informative audio sound from surroundings, right? So I think that would be the point.
I think the whole point is that you should turn off the ADC of the just in case of any potential risk. Okay, another question?
Sorry, maybe I missed that part, but so the audio that's being transmitted, so it's being processed by the CPU, and is it also being transmitted over the wire to the internet or over the network, or is it just being processed within the device itself?
Actually, we haven't done any experiment on the internet side. The only experiment we done is the link between the ADC and the CPU. So whether or not the CPU is passing on the information to the internet, we haven't audited it because we believe that our attack model is that the adversaries have access through the internet side and have the root access or other access, and think the the mute button is the ultimate defense, the final defense of the whole system. So I think that our scenario is that the internet side has been passed through. So I don't know if this is okay. Thank you.
I mean, after muted, the CPU still can get some information from surroundings. So maybe they are not transmitting now, but in the near future, maybe there's some attacks in there. We don't know that.
Okay.
All right. Any further questions?
Professor Li Kang.
Are you not?
Yeah, so this is related to the first question. I think what the people try to ask you is that can you identify the signal you get is really from the microphone or maybe from somewhere else? So I think that's important to know so that if it's really from the microphone, you can shut it down, right? Then my question really related to this is that how long the message will be, the hot mic effect. Like, say you can listen, you show the example, like you can listen for a while, but can it last for 10 seconds, 20 seconds, a minute? You know, how long that effect will be?
Okay.
Maybe we should play the video again.
Video again. I think the duration around is at least 60 seconds. And as a matter of fact, this video clip showed that after, I think, the 1 minute and 40 seconds, the signal is totally died down. So I think at least, I think the first 10 seconds is very useful. The first 10 seconds of the signal, the quality is very, very well. And after the 10 seconds to 60 seconds is, I think if we want to use this channel as a covert channel to transmit some information, we have to use some fancy coding like the LDPC or other things to make this channel useful. But I think the first 10 seconds is useful as a voice channel.
Okay, got it. And so I think that also gave you a strong clue where the information come from. So it's more likely from the microphone, not from others, right? Because you press a mute button, then after you press mute button, it only lasts, like say, 10 to 60 seconds. So it has to be from the microphone, not from some other place. That's what I'm thinking. Thank you.
Okay.
Yeah. Thank you. Thank you.
Are there any further questions? No? All right. Then Wang, Kang, and Yang Bo, thank you very much for your talk.
Thank you, guys.
Thank you.